Hello. Over the last couple of videos, we've been looking at the derivatives of these arc functions. And there's something I did that I think maybe overcomplicated instead of simplified these videos. Because I lied a little bit with the graphs I gave you. And when we went to define those ranges on those functions to take the derivative, I think that got confusing for some people. So I'm going to explain exactly why we had to make those steps. We had to take those steps, like making the range and things that we did on those steps when we turned the function y is equal to arcsine of x, or arccosine of x, or arctangent of x, and then turn those into functions of y. Well, not functions of y, but we turn those into expressions that compare x as if it were a function of y. And I think that got a little bit confusing, so I'm going to show exactly why we went between these steps. I'm not going to redo all of it, but I think that some of it was a little unclear because I did something with the math that isn't entirely accurate, and I don't think it helped the clarity in the way that I would hope that it would. So basically, these are the graphs of these functions: arcsine of x, arccosine of x, and arctangent of x. They come with these very limited ranges. So like the graph of f of x is arcsine of x doesn't go past this point here, or this point here. And it's the same over here on arccosine. And here, because of the, we've got these asymptotes here, it doesn't go beyond those. This has something to do with how the arc functions are kind of impure inverse functions. They're not perfect inverse functions because they don't actually output the opposite here. I think the best example is an example. So you cannot say that the arcsine of the sine of x is equal to x. That's the main issue with these, because arcsine only outputs, just as a formality, it only outputs values between pi over 2 and negative pi over 2. So this is not true, because what if you had some value of x higher than pi over 2? Well, in terms of the sign, it's not the issue. You're still going to get a function with the same sign that x has when you do this. So when you get this angle here, if you take the sine of that, it's going to be the same as the sine of x, but you might not get the same angle there that you had in here. And I hope that makes sense at least a little bit, and that goes for all of these functions. So arc cosine of the cosine of x is not equal to x necessarily. So they're not inverse functions in all cases, and that's the main issue here, I think, with what makes kind of deriving these derivatives complicated. So the graphs that I gave you in the videos before weren't these graphs. I gave you a different graph. I gave you graphs where this continued, where these functions, well, they're not functions anymore, where these relationships, these graphs continued in all of these directions. And those are not these. These are not the same. And it's kind of bad for me to circle them with the same color, but this green is not equal to the orange. That's kind of a bad way of drawing it, but they're not the same curve. The orange is just the thing inside the blue, and I think I'll circle it with that. So this here, these orange functions are drawn in blue, and that's their actual function. I haven't changed the domain or range or anything. As a formality, that is what these functions output. They stay within those bounds as just a product of how we've defined them in our various mathematical adventures. So, and that's not me, that's mathematicians. This is how those functions are defined. Instead, I gave you the curves, wrong color. I gave you the curves x is equal to sine y, x is equal to cosine y, and x is equal to tan y. And the change there was like that. There, I had these extra bands on here. But those are not equivalent because of this thing here, right? These aren't perfect arc functions, and I can do the same down here. Arctan tangent of x is not necessarily equal to x. So I've given you two separate functions here, and the function of the green and the derivative of the green function isn't the same as the derivative of the blue function, and we're trying to find the derivative of the blue function. But because of what was required to take the derivative, where we did implicit differentiation, we had to write them in this form. So when we were actually calculating the derivative, we had to write this in this form because we don't know how to take the derivative of arc cosine of x and our y or whatever. I mean, y is fine, but it makes our job much easier if we just turn these into these functions. However, we're not actually dealing with those green functions. So to make sure that we're dealing with the blue functions, what we had to do was say, okay, we need to change these green functions. So we're going to say x is equal to sine of x, but we're also going to say that y is less than or equal to pi over 2 and greater than or equal to negative pi over 2. And all of a sudden, that turns our green function into our blue function because it's walled off. So if you say x is equal to sine y, and y is between negative pi over 2 and pi over 2, then this whole thing suddenly becomes the same as that. And that goes for all of these, right? We said that I think y was less than or equal to pi and greater than or equal to 0. And I think down here we did y is less than or equal to pi over 2 and greater than or equal to negative pi over 2. So the reason that we did those bounds, and I think I overcomplicated it by not giving this information then, nonetheless, I think that the videos are helpful and that the method of finding the derivatives in those videos is accurate. It gives the right response. I don't think I explained it in the best way. But basically, the only reason we made these bounds was to change those green functions into the blue ones so that we could stay accurate. Once we actually find these derivatives in white, those are our final derivatives. Those are the actual derivatives, because just as a product of them coming from these functions, these blue functions, these bounds come with that. So the bounds are an assumption based on the function, because these functions are all between those bounds. The only reason I had to take that step of making those bounds is so I could say x is equal to sine y, x is equal to cosine y, and x is equal to tangent of y. That step was necessary to actually finding the derivative, but it was an inaccurate function unless I made those bounds. I hope this has cleared some stuff up. This f prime of x, g prime of x, and h prime of x down here, those are all accurate derivatives of the functions in orange, and I'm sorry for the confusion. Thanks for watching.